Hey everyone, in today's lesson I'd like to talk about animation, the procedural animation, the keyframe animation, how to mix them both, how to achieve a certain result, how to avoid some um, repetitive task by using a procedural method, and how to prepare geometry so you could um, procedural animated. Okay, and so yes, so these are some animations that I've prepared. So let's have a look how I actually made it. So here's the scene I've prepared, and uh, it has it has uh, like a keyframe animation and procedural animation as well. I will not go in depth of explaining everything because it's quite simple, if not very simple tutorial. So I'll try to be uh, short on explanation, but to give you an understanding how I managed to approach this type of animation that you have seen. All right, so uh, before starting the explanation, I'd like to say that I've done this project like a few years back. So I've done there is a mistake I've noticed while preparing the lesson. The mistake is the scale of the scene. So since geometry is being imported from uh, different software, it's not it's it was in different software, different scenes it were used. So it has like different scales, but overall I I created this. I used um, this main figure just to adjust the scene scale accordingly. Okay, it doesn't affect the animation, but for future works, I always start with the scaling, with a proper scale. Okay, so let me start with hide this one. So let me start with this office box, okay, which has the simplest animation. So here I have the scene, office scene, which actually had a very bad geometry to work with, and still it has there is few of them that I just decided to manually fix it. I couldn't even clean it up with the procedural method of HOUDINI, so I had to work a little bit manually. Okay, um, so this is what I think you need to pay attention before you accept a model from let's say model department, okay, or from other specialist. So let me hide everything and start with the first one. So here I have the chair, and I usually whenever I have a scene, I choose I position my camera first just to have everything in composition in the view right. And whenever I'm satisfied with the view, I start model this the way I could just feel that composition in kind of a so it could have a nice flow. All right, so here I have chair, which I decided simply I use the rotate and translate values being animated. Okay, so all of that, it was like they have some geometries inside the subnetwork, so which I parented and simply animated those parent nodes to make things fast. Okay, so here's the chair. All right, the next one is the flower. So flower is being scaled and overall scale first, as you see, and then Y scale as it would appear like that, because there is a lot of geometry, and I simply, and it's not a hero object, so just like an additional object, so I decided to animate it like this. All right, next one is the monitor. There's the monitor as well. Let me switch to this. All right, nothing complicated. Scale and Y as the flower and the overall scale. Next one, the second monitor, the same animation but with a slight shift, so we could have a little bit offset, because as we know, animation loves offsets. All right, so here's the table. We have it like we have some rotation and scale as well. All right, and here is the length of the table. So as the legs grow, tabletop appears, and the monitors appear as well. Okay, there's the lamp, the secondary objects, they just come afterwards. Okay, and some additional details. The same scale, translate, and rotate were used to animate all of this geometry. All right. Next, we have table B. So let me just look through the camera. So this way we have like one table has the same animation as the first one, but with the offset. All right. So here we have 1, 2 growing, and as you see, by using a simple animations, we can achieve a nice compositional animation. Okay. All right. Next is the let me just, so here's the keyboard we have. Right, you see all the buttons also animated. So the thing is that I use it as a single object, as one object, and I sorted out by using a connectivity. I'm separating geometry which has a connection between primitives. Okay, and here I'm using for each by using the primitive class, and here I'm simply, again as usual, I'm using simple transform animation, and then by using a metadata, I'm time shifting to create time shifting with the multiplication by a certain value to speed or to slow the animation. All right, so this way you have a little offset of your animation. If you dial in bigger numbers, it will end up animating very slowly. Okay, then overall the global animation just to fit the whole animation. So all right, so it would appear afterwards. Then this extra This extra, I've used the same technique, okay? So by using the class and basic transforms, all right, and yeah, class, primitive class attributes, and using metadata to offset my animation with the global time shifting. I'm just having it timing right, all right. Now the bookshelf. So the bookshelf, I have to recreate it because the original bookshelf that I've been sent was very bad topology, and it absolutely it should be better to create a new one than use the original bookshelf. Okay, so here I have my bookshelf, and here I'm using a bounding box, and with point from volume. I give it a little transform, sorting out, and then I'm using the Voronoi fracture to fracture my geometry. Okay, here I have the bigger pieces, but using the points from volume, I'm splitting them into smaller pieces. Okay, then filling by fracturing the pieces, we're creating a piece name attribute. Okay, so here on for each loop, I'm using this name attribute, which have been created by using Voronoi fracture, and the same technique is here, just simple transform, animation, and time shifting with speed, and global time shifting. I'm getting this type of animation, just very simple. Okay, then books were the same. I had to manually create one book and then just replicating them by placing onto the shelf, then using the class primitive attribute, the same method of animation, just global time shift, and let's see everything together, and we have our bookshelf with books filling the shelf. Okay, and last, this primitive and this box has the same animation as previous animation that I've have shown to you. Okay, nothing special. And here as well. And now if we just switch to a camera, so you may see with a couple of simple animations and use of manual animation with procedural ones, you can achieve a certain result in a very short time. The preparation is the only what takes a lot of time. And here, if you're interested, I just left some unanimated geometry. Maybe if you'd like to test, if you like those methods, you may just test yourself and animate those remaining objects. Okay, so here we're done with the office, and now with the shelves. So the idea behind the shelves, so we have let me go back. We have an older version of shelf which is transforming to a new one. Okay, so the idea, the main idea is to transform the first shelf into like to create an animation of disassembling object, and then create assembling one with a newer shelf, and blend them so that it would look naturally. All right, so let's really run fast. So here I have an older shelf, so I have to create a disassembling effect. I'm trying to split geometry onto onto similar pieces. Okay, so then I could use a procedural method to animate them. So here I have excluded the doors of the shelf, and here I am also on remaining on the horizontal geometry. Then I use the method that you've seen before, like bounding everything and creating points from volume. Okay, and then I'm fracturing to smaller pieces. Okay, and then I do a sorting, so I could have a random animation. So as you see, and then adding a class attribute to my primitives, and then doing the animation as the same as you've seen before, by using the simple transform time shift with the multiplication. All right, the same is here, so we get something like this. All right, and here here we have doors. So I'm splitting the doors onto two parts. All right, so I have like left doors and right doors, and what I do in here I'm sorting as well, just to give some randomness, and I'm using the same technique, class primitives. The only difference here, let me merge them and we'll see. As you see, they animate differently. The animation is the same, but the rotation value is a little different. What's happening here, I'm using the pivot translate value, in this case as x minimum, so the pivot point will go of this part of the geometries, it will go on the one side, while using here I'm using x max, which gives me pivot translation on the other side. This way you'll get different type of animations. Okay, all right, and then time shifting just to fit the overall animation. Okay, as you see, if we just look in the smooth version, all right, I think it looks nice. Then I actually had to disappear this object, but I did it like an opposite way. So I'm using the time warp and I'm reversing my animation. So here I have this, it's the shelf being disassembling. Okay, also here I'm, in case I want to offset the overall animation, I just keep this in advance, and here I'm using this basic transform just to fit the width of the future shelf. Okay, so something like that, and scaling and onto the y-axis as if it would grow upwards, and the rest animation will happen. Okay, so here here we have the new shelf. What I'm doing here, I'm not going through the door animation, so it is the same as I showed you before. So it has the same pivot offsets, and that's it. And here I'm using the same technique. I'm separating the uh, same type of geometry, this horizontal geometry in this case, which I split, and I do an animation. All right, so you may see, so here we have, and the vertical ones, they are also have just a simple animation, but together it looks interesting, with the doors. All right, and some time shifting, sorry, just to mix them together. So here, just as a preview, here I have my red disappearing while green is appearing. All right, so yeah, this is the animation. So here you see we just use all of procedural method. So the second one would be slightly complex in terms of having some manual keyframe animation, just to have different transforming animation. Okay, so here as well we have the older geometry and the newer shelf. So again, here I'm splitting the horizontal one, and in the vertical one, here I'm keeping all this sorting in case I would need it. But the point here, I'm doing keyframe animation. All right. So the second one, I'm separating. I'm doing a separate animation in case if I spoil everything, I could just delete the node and start without losing all of the good animation that I kind of approved by myself. All right. So here I have objects animated separately. See. So here's the last one. So I could use a procedural method, but the thing is, I have a slight shift because I wanted to fit those horizontal geometry to fit the newer geometry. There is a slight offset between those horizontal planes, so this way I had to do it manually. Okay. And here we have a vertical geometry, which I also I'm shifting and trying to fit the newer geometry. For, let's say I do a template, and just to shorten those explanations, as you see, I'm doing a fit and I'm hiding my geometry. All right, so here I have my older geometry, which is transforming into a new one. All right, here we have the doors again, which we already talked about. All right, and here we have our disassembling animation. This time warp is the same, offset is the same, and let's quickly run through the so here I'm sorting by Y. This way my animation will look like that. It's like from bottom to top. I think here as well we're using, and here here I'm separating just to have a different animation types. Okay, so and we have here like one geometry moving to the right and another one moving to the left. All right. This way we have some differences between. So here we have this kind of animation. All right, and these are the doors. So together it will look like that. I think it looks very nice. And also we used only procedural method in this case. Again, time shifting, just fit things together to look good. As you see, I think it looks nice. And here I'm extending my animation, just elongating my animation just to make it slower. Okay, so all these three type of shelf animation could fit the same have the same speed. All right, okay, and the last one, which have more of the manual animation, and also there is two type of animation. So I was just thinking, how far can I push like mix with procedural one and manual animation. All right, so here we have the older shelf. Here I'm creating a box covering the whole shelf, and here I'm creating I'm splitting my box onto several polygons. So I have a vertical, a horizontal, and a back polygons. Okay, so here I have the side one, which I'm extruding, adding normals, reversing them. All right, and then duplication on Y and on X. All right, the same is the horizontal geometry and the back side geometry. All right, so and here I have an animation. So this is the overall animation. Again, I'm trying to fit the newer shelf, and here I'm shifting few of the pieces just to have some difference. All right, and just to look at the final one, we have we're hiding some of the geometry, but leaving the ones that we will use later. Okay, here what I'm doing, I'm freezing my animation here, deleting all of the geometry, but the first row, the top row, I'm keeping it. So I'm doing an animation. I'm scaling it. So I want to create a few layers of this shelf, just to fit the scale, fit the height of the newer shelf. Okay, so this way I have this kind of a movement here as well. And if I look at the final one, so here I have like my shelf being prepared and growing up just to fit the height of the newer shelf. Well, so here we have, and then there is a lot of manual work, so I'm trying to fit all those geometry to a newer shelf. Okay, so simply as I said before, I'm trying to do my animation separately. This way I could avoid save myself from problems that I could have later on. So by animating one by one, I keeping myself from breaking everything, okay, and then start all over again. So here here I have the kind of result. So I'm managing to match the overall shape of the newer shelf, okay, but still I'm having those small gaps, which will take you a lot of time, which I which I'd like to avoid. Okay, so to fill all these gaps, I use the original, so the new shape where I'm using the geometry of the new shape. Okay, so I'm doing this uh, scale animation. So it has like an extrusion type of animation. Okay, and here I'm using the switch node, so I don't see it in the scene. Okay, so it appears like that. And so this is the last thing. So I have this geometry being trying to match the original, the newer shelf. Okay, and when it's ready, the original geometry just fills it. All right, this way I'm filling all those gaps. All right, so this how it was done. Then here what I have here I'm trying to uh, to kind of to transform this shape of the older geometry into this shape. Okay, so this way here I'm also excluding the horizontal geometry, and I'm trying to match this shape. All right, and here we have a vertical geometry, which I also try to. So here it has the original pattern of all the geometry. By moving them to the sides, I'm creating equally shaped geometry. Okay, and this way I'm merging them together. This way I have transforming the older shelf into a kind of a equal type shelf, which we are using as a transformation effect. And then here I have, these are the doors. Just simply scale them into different axes. All right, and here I have the older shelf being transformed, and here I'm filling it with the prepared shelf. All right, and here what we have in the end. So here here I have the older shelf being transformed into that prepared shelf. All right, this is the first step, and then it transforms into the newer shelf. All right, this this was the purpose of all this animation preparation. Okay, so after this one has been prepared, the only thing we need are the doors, which we already know how to animate. So we have this being prepared, and the doors appear in the end. So yeah, so this type of animation, if we look on a smooth version of that, it looks very nice. Okay, and the last one is almost the same, but maybe with a slight shift. So here again, I'm excluding the horizontal shapes. I'm doing this kind of a scaling again with the matching to the newer one. Here we have the vertical ones. All right, also matching the shape and scaling down. All right, and this all together. And of course, with the doors, we have only applied scale to our doors. Nothing special. All right. And the newer one, here we have the doors, and also here we have a horizontal one, which is again by Y axis was sorted and growing from bottom to top, and the vertical ones was sorted and splitted by using the class that is modules by 2. If it equals 0, then we have the number of geometries, and if it equals to 1, it's second half of geometries. Okay, and animated as well. So this type of animation, and merge everything together, and here we have the type of animation transformation. As usual, time shifting, speeding things up, coloring. So this is what we have, like all right, and the final result. All right, a little slow. Well, yes. So this is the this is what you can achieve by using a procedural method with some preparation and adding some keyframe animation, which creates some uniqueness to your gives some uniqueness to your animation, and you can achieve some different results. All right. And the also advantages, you can change things by using like by splitting your work into smaller pieces, so you can avoid bigger problems later on, and redoing things as well. You can just change a few parameters, and that's it. Well, that's all I want to share with you in this lesson. I hope you liked the lesson, and if it was useful, please subscribe. Thank you very much for your attention. Goodbye and good luck.